Hey everyone, in this video we're going to continue evaluating functions. Our first example, given f of x equals 5x minus 6, evaluate the following. First, f of negative 3. So our input is negative 3, what is the output? Remember, that's telling us that x equals negative 3. Now in these examples, let's try to do it without writing x equals negative 3. So we're going to substitute negative 3 in for x. Right, negative 3 is our input. So we simplify, so f of negative 3 equals negative 15 minus 6. So f of negative 3 is equal to negative 21. F of 7, our input is 7. So we're going to substitute 7 in for x in our function. So 5 times 7 minus 6. So f of 7 is equal to 35 minus 6. F of 7 is equal to 29. F of 2b. So this is different because our input now has a variable in it. But we're going to proceed the same way. So our input is 2b. So we're going to substitute 2b in for x. So we have 5 times 2b minus 6. So f of 2b is equal to 10b minus 6. Now these aren't like terms, so we can't simplify any further. Don't get caught up in the fact that there's a variable in our input. Our approach is exactly the same. Identify our input, substitute it in for our x values in the function, and then simplify. So turning our attention to the next example, f of x plus h. This looks even more complex because not only is there a variable, but it's a binomial, x plus h. Again, we proceed exactly the same way. So our input is x plus h. Right? So this whole piece is our input. So we're going to replace x in our function with the quantity x plus h. So 5 times x plus h minus 6. So f of x plus h is equal to, we'll distribute the 5, so 5x plus 5h minus 6. Now this looks even more complex than the last example, but it's a completely correct answer. We input x plus h into our function, and the output is going to be 5x plus 5h minus 6. So these are the examples that we're going to work through in this video. Next, we're given g of x equals negative x squared plus 6x. Evaluate the following. G of t cubed. So our input is t cubed. So we'll substitute t cubed in for all of our x's. So negative t cubed quantity squared plus 6 times t cubed. So we're going to simplify. So g of t cubed is equal to negative, so t cubed to the second power, we multiply our exponents. So we have t to the 6 plus 6t cubed. We don't have like terms, so that is our output. If we input t cubed in this particular function, our output is negative t to the 6 plus 6t cubed. G of a minus 1. So our input is the whole expression a minus 1. So wherever there's an x in our function, we're going to substitute in a minus 1. So we have negative a minus 1 quantity squared plus 6 times the quantity a minus 1. Substitute a minus 1 in for each x in our function. Now we have to simplify. So this is a good reminder that a minus 1 quantity squared is a minus 1 times itself. So we would get a squared minus a plus 1, which is a squared minus 2a plus 1. You don't have to do that work off to the side, but it's a good review. So we have negative, so equals negative, g of a minus 1 equals negative a squared minus 2a plus 1. And we'll distribute the 6. So plus 6a minus 6. we have g of a minus 1 equals, now we have to distribute the minus 1. So we have negative a squared plus 2a minus 1 plus 6a minus 6. So we can combine our like terms. So we have negative a squared plus 8a minus 7. Now, a lot of old material came back in these last two examples. We reviewed properties of exponents when we input t cubed into our function, because we had to evaluate t cubed quantity squared. Then we practiced multiplication of polynomials, right? A minus 1 quantity squared. We did our work off to the side, so that's a minus 1 times itself, and practiced multiplying out. And we also practiced adding two polynomials, combining our like terms. So when our inputs are variable expressions, a lot of our old material is going to come back. Still the same function, g of x equals negative x squared plus 6x. Now we're evaluating g of x plus h. Again, there's an x here which throws it off a little bit, but remember, this whole expression, x plus h, is our input. So we're going to substitute in x plus h for each x in the function. So we have negative x plus h quantity squared plus 6 times x plus h. So notice I substitute in x plus h in parentheses for each x in the function. Now we have x plus h squared, so g of x plus h is equal to the negation of x plus h times x plus h plus 6 times x plus h. Now we can multiply, so g of x plus h equals the negation of x squared plus xh plus xh plus h squared plus 6x plus 6h. Combining like terms in the parentheses, we have g of x plus h is equal to negative x squared plus 2xh plus h squared plus 6x plus 6h. We can distribute the negative 1. So g of x plus h is equal to negative x squared minus 2xh minus h squared plus 6x plus 6h. Notice there are no like terms, so our output in the function g of x, when our input is x plus h, is negative x squared minus 2xh minus h squared plus 6x plus 6h. Okay, so we had a lot of simplification in this example, but the important piece is how we start, making sure that we substitute the input of x plus h correctly into our function. So substituting in for each x in the function, x plus h in parentheses. Now the average rate of change. If you remember when we did that earlier, the average rate of change was just another way to say slope. So what we're going to do is find the average rate of change of a function over a given interval. So that will tie in the idea of average rate of change, or finding slope, with our new function notation. So to start us up, what is the average rate of change between the points below? So the points are negative 6, 1 and 2, 3. So the average rate of change is the slope. So y2 minus y1, so 3 minus 1, over x2 minus x1, so 2 minus negative 6. So the numerator, 3 minus 1, becomes 2. In our denominator, 2 minus negative 6 is 2 plus 6, which is 8. So reducing our fraction, we get a slope of 1/4. So the average rate of change is 1/4. So now let's take this same problem and use function notation. So find the average rate of change of the function on the given interval. So f of x equals negative 2x plus 11, and our interval is 0 to 8. Now this interval is x values. Okay, so this is saying from x equals 0 to x equals 8, what is our average rate of change? Well, in order to figure that out, we need the y values, or the output of the function at x equals 0 and at x equals 8. So we'll start by finding those two outputs. So if we input 0 into our function, we substitute 0 in for x, so we have negative 2 times 0 plus 11. So f of 0 is equal to 11. Inputting 8 into our function, we have f of 8. So we're going to substitute 8 in for each x. So we have negative 2 times 8 plus 11. So f of 8 is equal to negative 16 plus 11. F of 8 equals negative 5. So we have 2 points then. We have the point 0, 11 and the point 8, negative 5. And we're finding the average rate of change between these 2 points. So the way function notation came in is we input our x values into our function to figure out the outputs and use those outputs as the y coordinate in each point. So the slope, or the average rate of change between these 2 points, negative 5 minus 11 over 8 minus 0. Our numerator, we have negative 16. Denominator, we have 8. So the slope is equal to negative 2. So the average rate of change is negative 2. Okay, so we worked a couple ideas in here. The idea that average rate of change is equivalent to slope. We now have function notation. We're going to use our function to find the outputs, which will be the y coordinates of the points. The x values we get from our interval, and this is interval notation. Right? Think of writing this as an inequality. This would be 0 is less than or equal to x, which is less than or equal to 8. Right? Only the x value, or the x variable, would be used in that inequality. So 0 and 8 are both x values. Find the average rate of change of the function on the given interval. So the function now is f of x equals x squared minus 3x plus 6, and the interval is negative 2 to 1. So again, we have x equals negative 2, and we have x equals 1, and we have to find the output for each input. So we'll start by inputting negative 2 into our function. So we'll substitute negative 2 in for each x. So we have negative 2 quantity squared minus 3 times negative 2 plus 6. So we have f of negative 2 equals 4 plus 6 plus 6. F of negative 2 is equal to 16. And then we'll input 1 in, so f of 1. We'll substitute 1 in for each x. So we have 1 squared minus 3 times 1 plus 6. So f of 1 is equal to 1 minus 3 plus 6. So f of 1 is equal to 4. So our 2 points are negative 2, 16, and 1, 4. So we can find the average rate of change, or the slope between our 2 points. So that's going to be 4 minus 16. That's the change in y. 1 minus negative 2 is our change in x. In our numerator, we'll have negative 12. In our denominator, 1 minus negative 2 is 1 plus 2. So that's 3. So our slope is negative 4. So our average rate of change between those 2 points is -4. Okay, so we looked at some different questions in this video. We looked at evaluating functions where the input had a variable in it, and we don't want to change up our approach. Still taking the same approach of using the input, substituting that in for each x variable in our function, and then simplifying. Now, when we simplified in a few of those examples, we had to use some past ideas, right? Properties of exponents, multiplying polynomials. Few of those concepts came back into play. We also revisited the idea of average rate of change, or finding the slope between 2 points, where we had to use the function to find our output so that we can create our 2 points to find the average rate of change between. So now that you've seen a few examples, practice, do a few more on your own so that you get comfortable with these ideas. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.